Okay, so let's start here. I believe I came up with a representation of this a couple days ago. It may have been yesterday when Michelle was asking about it. Okay, so the meaning of x, and this is the meaning of this whole statement right here, is the difference between x and 2 is 4. The difference between x and 2 is 4. So if I'm right here at 2, and I'm saying the difference between x and 2, oops, why am I over here, is 4, then that would be 1, 2, 3, 4, and 1, 2, 3, 4, right? So the solution to that would be x could either be 6 or x could be -2, because both of those numbers are 4 units away from 2. So today, and then when we did this graphically, I have it on the next screen, I'm just going to pull it up, it'll be faster. So graphically, we had x minus 2, which is a parent graph right here, right, with no rate of change. The rate of change is just 1. It's shifted over. Oh, they're not connected. That's unfortunate. I will connect them. Okay, so they're shifted. Right here, this says shifted to the right 2, so we shifted over to the right 2. And then we say equal to 4 is a straight horizontal line right there at 4. We're going to say that's 4 units up. And the intersection is right here. That's how we did this graphically. So check this out. The next thing we're going to do is, instead of saying equal, we're going to say, I wanted that to be white. Instead of being equal, we're going to say greater than now, because it's an inequality. So where is this v, where on the v is greater than 4? Can you guys visualize it? Let's bring up this one. So where am I going to shade? Am I going to shade above the 4 line, or am I going to shade below it? Above it, because it's greater than. I'm going to shade above it. So if I shade above it, and I'm saying I want all of the values of x that are greater than that line, aren't those values really all right here, going on to infinity, and all the values here? So that's where the graph's going, right? The graph isn't going in here at all. It's just going out here. And if I apply that to the number line, it's where x is greater than 6, right? All these values being greater. So right here it's greater than 6. So on this number line, I could actually shade here. Or either this is occurring, x is greater than 6, or x is less than -2, which is all the values here. So I'm taking an Algebra 1 concept of shading a number line and solving inequalities, and I'm making a graphical representation. Okay? Are we ready? No? I've told you, it's abstract, right? It's pretty abstract, but if you think about it, it's also very simplistic. I know those are opposites, right? But it is, if you think about it. You just can't make too much of it. It looks very different, very strange, very abstract, but it's actually very simplistic. Where all we're talking about is it above the red line or below the red line? Okay? And as long as you keep it that simplistic, it shouldn't be too bad. So if I was talking about everything, let's just copy and paste this. Copy this one, and this time I'm going to say everything that is less than my color. Get rid of this. Get rid of that. Get rid of this. And then I want to talk about less than. So where is the v, the absolute value v, right, graph? Where is it less than the line? It's below it. Well, what are all the values on the number line that are below? Isn't that here on my graph? All of these values are all below. They're all in this area right here. So x must be in between 6 and -2. Make sense? All the values of the v that are below are everything that's right here in between. Right here. All these values are solutions. Yeah. Would it be included? Why, Andrew? Do you know? I like that idea, but that's not exactly why they're not included. Look at the original problem. Are these included? Is this included? What would make it included? If I had a line here, then you would need that here as well, and that would make these. This is open. That would make it closed, but we're not going to have it closed. We're going to have it open. I think we should just practice it. Yeah? Okay. I think that's going to be the best. So I can stand up here and talk about it all day long, but I think the best thing to do is just practice it. Okay, I'm not going to worry about that. I'll just keep these in here in the presentation for you guys to go back and look at. Okay. So f of x is equal to x minus 2 plus 4. I'm going to change that and put that into transformational form. So I'm going to say y minus 4 equals absolute value of x minus 2. So I know that that's a horizontal shift to the right too, and it's a vertical. This is my horizontal shift here, and here is my vertical shift. So I'm going to go over 2 and up 4. 1, 2, 3, 4. There's my vertex. My rate of change is 1 because there's nothing in front of there. So up 1 over 1 in both directions. G of x is at 7. So 7 is right here. That didn't work out very well. Better. All right, so the first question says, first of all, when are these functions equal? Well, we've already been doing that, right? These functions are equal. Right here. We should probably use a different color. Let's use, I'll use red. So they're equal when x equals, I'm going to use the bottom one, the one that's less, the first. So x equals -1. And the other one is 1, 2, 3, 4, 5. X equals 5. That's when they're equal. When is f of x greater than g of x? So I'm going to, it's greater than all the values above the line. So all of these values. Everything where the graph is going this way, going up. So that would be when x is greater than 5, or when x is less than -1. When is f of x less than g of x? it's below all of these values right here, right? Everything in here is less than that line there, which we can say is everything in between. So x is in between 5 and 1. Negative 1. Thank you. Okay, questions so far? No? Okay. So I think I'm going to take you to one more thing before I start. I think we just need to start our homework. I want to give you lots of time in class to do this. These will all be, I'll let you write those notes tomorrow. Can you guys show me on a whiteboard? Can you do this one for me really quick? A little rusty with my recording. Okay, so we're actually splitting these two functions up, right? So this is, my first function is when y equals, sorry, I want to change my color here. When y equals 4 times the absolute value of x. And my second function is when y equals 8. So we don't make this absolute value, we don't make it a dashed line when normally we would, because right now we're just talking about the intersection. Does that make sense? Otherwise, yes, we would. We would definitely, if it was just graphing an inequality that was absolute value, yes, it would be a dashed line. But since we're graphing two functions and comparing them, it's not. Really, really good question. So our question is, which one is it? Is it in between or is it an or statement? I'm going to give you a little hint here. There's a way to know when you're just looking at this sign right here. Less, this is how I remember it. Less than this is how I write it. Less than. This would be an and statement, right? Because both things are happening. Great or, if it was something, I think the next one is a greater. If it's a greater than, I say great or. That's how I remember it. So or is one or the other in different directions, right? And less than goes like this. So I want everybody to do that. Put your hands up. So less than and great or. Okay. And or. One way or the other. Okay, perfect. All right, so almost all of you, so since this is less than, it's going to look like this, right? And so I'm going to graph them. So for x, the vertex is at 0, 0, and it's up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Where is that absolute value graph intersecting 8? At 2 and negative 2. So right here. At 2 and negative 2, but when we want to talk about everything that is less than that red line, it's everything in between. So I would say x is in between 2 and negative 2. Because the graph is in between, not for. Questions? Do one more? Yes? One more and then I'll pass out homework? Okay. I'm going to go ahead and give your homework out and have you guys do this one at the same time. Pausing. Okay, so I walked around the room and there's still a little bit of confusion. I think we just need to practice. Okay, so I'm going to separate these two functions. I have y equals absolute value of x minus 2. This negative 2 belongs to x? No, it belongs to y. So I'm going to go put it with y. That's transformational form. And actually, if we wanted to, we could put minus 0. There is no transition on the x-axis, or transformation on the x-axis. Then my other function is y equal to 3. So I'm going to graph for my first function. My first function is going to be shifted nothing on the x-axis, but shifted down 2 on the y-axis. And again, there's no rate of change. There's no slope. And then my other function is a horizontal line at y equal to 3. So I can say that my functions intersect when x is 1, 2, 3, 4, 5, and negative 5. But my only question is, am I talking about greater than the line or less than the line? Greater than the horizontal line. So great or means everything, and the arrows can tell you. The arrows are going to tell you exactly what the answer is. Look at greater means everything out this way, right? And everything out this way. So that can tell you exactly your answer right there. The arrows just told you. X is greater than 5 or X is less than 5. And I'm forgetting less than or equal to because of this right here. What? Both answers. This? Both of these? Absolutely. Because if I were to say something like, what would I do? Thank you. Right there. They are included because of the original problem was included. Okay. Chris, the reason is that if I said something like, hey, can x be negative 6? Yes, it can. If I didn't have this statement right here, Chris, I would say, I don't think so. Because this means x can be anything that's bigger than 5 or including 5. And here's the reason. Let's plug it back in. So x could be, let's use 10. Could x be 10? This statement says x could be 10. Let's see. If x was 10, would it work back in the equation? Absolute value of 10 is just 10. Minus 2 is greater than or equal to 3. 8. Is 8 greater than or equal to 3? Yes. Let's put in something else. What about negative 15? Something way out here. X can be anything that's smaller or equal to negative 5. So something smaller would be negative 15. Let's see if it's true. The absolute value of negative 15 is positive 15 minus 2 is 13 greater than or equal to 3? Yes. Let's try something in the middle. Let's try a value in the middle right here. Let's try 0. So 0 minus 2. Absolute value of 0 is 0 minus 2 is greater than 3. Is negative 2 greater than or equal to 3? No. Doesn't work. So then you can always test it. Does that make sense? So if you're worried about your signs, you can always test it. And the easiest number to test is 0, right? Okay, I have one more thing to show you. Special cases. Check this out. So we can have negative signs on this side right here because we're talking about greater than and less than. We're not talking about it being equal to a negative number. We're just talking about whether it's greater than a negative number or less than a negative number. So let's look at this graphically. So here's my graph. Here's my absolute value of x plus 3. And here's my graph of negative 2. All right? Where is the v, the absolute value graph, greater than the line? Where is it greater than the red line? What part of the graph is greater than the red line? The whole thing. So what do you think the solution is? All real numbers. Because the whole graph the whole thing. If I'm right here on the graph, if I'm here on the graph, am I above the red line? Oops. If I'm here on the graph, am I above the red line? Here, 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 everything, the whole graph in both directions. So I would say x is an element of all real numbers. Okay, so that's one special case. What do you think the other case is going to be? Andrew, you're so smart. Where is the graph below the red line? Never. It's not. So this is no solution. So graphically, it's pretty easy, right? If you just look at it, it's never below the graph is never going to be below, so it's no solution. Okay, I'm going to turn you loose on your homework for about 5 minutes, and then we're going to check in, and so you guys do 1, 2, and 3, and then I'll show you the answers. Make sure that we're going okay. If you need any help from me at all, I'll come over and help you. Okay? So I'm going to stop recording. Good job, guys. Bing. Okay, so here's the answer to your first 3. Does anybody have any questions? See how I highlighted? Is that better? There we go. Okay, so on this one, if we're talking about less than, we're talking about just this part of the V is less than the green line. So I drew it in here on the x-axis as well, because that's what we're talking about, x. Here, it's where it's below the line. So where it's below the line is this part of the V, is below the line. So since that's the only part of the graph below the line, I can only shade that part of my number line. This one is where it's less than the green line, so the graph is only less for this part. I can only touch this part of the graph, therefore I can't go any further out here on the x-axis. I can only stay right here. How are we doing? You want me to put up 4, 5, and 6? That way you've got a reference for it? Great. There you go. Actually, let's take a screenshot of this one so I can put it inside of the presentation. Let me just screenshot this. And then I'll screenshot the other one. All right, fantastic. I think we're done.